Here's a bold prediction that might ruffle some feathers. The future of computing isn't going to be dominated by Intel or ARM. It's heading straight toward RISC-V architecture, and the Orange Pi RV2 might just be the affordable proof of concept that changes everything. Picture this scenario. You're standing at the crossroads of a technological revolution, where a mere $40 can unlock access to cutting-edge RISC-V computing that industry giants are betting billions on. The Orange Pi RV2 isn't just another single-board computer cluttering up the makerspace. It's a strategic gateway into an architectural philosophy that's fundamentally challenging how we think about processors. Equipped with an 8-core RISC-V powerhouse and packed with connectivity options that would make boards twice its price jealous, this compact computing marvel is specifically engineered to capture the attention of developers, electronics enthusiasts, and industry professionals who understand that the next big thing often arrives in small packages. But here's where it gets controversial. This isn't your typical desktop replacement. And that's precisely where the heated debates begin. While the RV2 demonstrates remarkable prowess in specialized domains, like Internet of Things applications and lightweight artificial intelligence tasks, it deliberately sidesteps the traditional performance metrics that most consumers obsess over. This intentional limitation creates a fascinating paradox that's dividing the tech community. Can a device that costs less than a nice dinner truly deliver meaningful innovation? Or are we simply witnessing another case of marketing hype disguised as revolutionary technology? Throughout this comprehensive analysis, we'll dissect exactly what makes the Orange Pi RV2 a standout performer in its carefully chosen niche, examining everything from its impressively energy-efficient architecture to its surprisingly versatile hardware capabilities. You'll uncover how features like dual NVMe storage slots, comprehensive GPIO interfaces, and AI-optimized processing units create unprecedented opportunities for industrial automation and IoT deployment, while simultaneously discovering the very real constraints in software ecosystem support and desktop computing performance that keep this device firmly planted in specialized application territory. Whether you're a hands-on experimenter eager to dive headfirst into RISC-V exploration, or a professional engineer searching for cost-effective solutions to tackle specific industrial challenges, the RV2 presents a compelling case study in strategic compromise. By the time we've explored every angle, you might find yourself fundamentally reconsidering what's actually achievable with budget-conscious single-board computing. And that's where the real controversy begins. Comprehensive Orange Pi RV2 analysis, essential information summary. The Orange Pi RV2 represents a strategically positioned single-board computer built around an 8-core RISC-V processing architecture, specifically targeting developers, hobbyists, and industrial users who prioritize lightweight AI capabilities and automation functionality over raw computational power. Connectivity options span an impressive range, incorporating Wi-Fi networking, Bluetooth 5 wireless communication, dual gigabit Ethernet connections, USB 3.0 interfaces, USB Type-C connectivity, HDMI video output supporting 1080p resolution, and comprehensive GPIO hardware interfaces, creating a versatile platform perfectly suited for IoT implementations and industrial applications. Performance characteristics reveal a mixed profile, delivering excellent results for lightweight media consumption and fundamental AI processing tasks, while struggling with demanding desktop computing requirements, high-resolution video processing, or sophisticated AI workloads that require significant computational resources. Energy efficiency emerges as a fundamental strength, featuring remarkably low power consumption metrics of approximately 1.5 watts during idle operation and 5 watts under full computational load. making it exceptionally well-suited for continuous operation scenarios in IoT deployments and industrial automation environments. Starting at the accessible $40 price point, it delivers an affordable introduction to RISC-V computing architecture. Though limitations in desktop performance capabilities, thermal management systems, and comprehensive software support make it significantly better adapted for specialized niche applications, rather than general-purpose computing scenarios. The Orange Pi RV2 derives its computational power from an 8-core RISC-V processor that's been specifically optimized to handle lightweight artificial intelligence workloads and industrial automation tasks with remarkable efficiency. This architectural choice represents a deliberate departure from traditional ARM and x86 designs, embracing the open-source philosophy that makes RISC-V increasingly attractive to developers who value transparency and customization flexibility. Memory configuration options provide strategic scalability across 3 distinct tiers: 2 GB, 4 GB, and 8 GB variants, allowing users to select the precise memory capacity that aligns with their specific project requirements without paying for unnecessary overhead. For storage capabilities, the board demonstrates exceptional flexibility through its comprehensive options, featuring dual NVMe slots for high-speed solid-state storage, eMMC support for integrated storage solutions, and traditional SD card compatibility for removable media applications. This multi-tiered storage approach accommodates both high-performance storage demands and portable media requirements across diverse use cases. Connectivity represents one of the RV2's most compelling differentiators, offering an extensive array of options designed to address various application scenarios. Wi-Fi and Bluetooth 5 provide reliable wireless communication channels, essential for IoT implementations and remote monitoring applications. The inclusion of dual gigabit Ethernet ports significantly enhances wired networking capabilities, making the device particularly attractive for industrial environments or server-like deployments, where network redundancy and bandwidth matter. 3 USB 3.0 ports combined with a USB Type-C connection ensure broad compatibility with modern peripherals and accessories, while HDMI output capabilities enable display connectivity, though video output remains constrained to 1080p resolution. The GPIO interface opens up extensive possibilities for direct hardware integration and automation projects, making it an ideal choice for developers working on embedded systems or industrial control applications. These comprehensive features collectively establish the RV2 as a remarkably versatile platform, capable of supporting applications ranging from basic IoT sensors to sophisticated industrial control systems. Though its true strength lies in specialized rather than general-purpose computing scenarios. Performance analysis, capabilities, and constraints. The Orange Pi RV2 delivers a distinctly mixed performance profile that simultaneously impresses and disappoints, depending on your specific expectations and use case requirements. Video playback capabilities support 1080p media consumption smoothly and can technically handle 4K content. This performance level makes it perfectly adequate for lightweight media applications and basic digital signage scenarios, but falls considerably short of expectations for high-end video processing tasks or demanding desktop computing workloads. Benchmark comparisons position the RV2 in an interesting middle ground within the single-board computer ecosystem. It consistently underperforms compared to the well-established Raspberry Pi 4 in overall computational metrics, yet significantly outpaces the Raspberry Pi 02W in most testing scenarios. This positioning establishes it as a mid-tier option, suitable for basic computing needs that don't require cutting-edge performance, but demand more capability than entry-level alternatives can provide. Artificial intelligence capabilities represent both a strength and limitation, depending on your specific AI application requirements. The processor handles fundamental tasks like object detection and simple machine learning model execution adequately, making it suitable for basic computer vision projects or lightweight neural network inference. However, it struggles significantly with more computationally demanding workloads, particularly when attempting to run large language models or advanced AI applications that require substantial processing power and memory bandwidth. And this is the part most people miss. The RV2's performance limitations aren't necessarily flaws. They're deliberate design choices that prioritize energy efficiency and cost-effectiveness over raw computational power. Understanding this philosophical approach is crucial for setting appropriate expectations and identifying suitable applications. Software environment and user experience. The RV2 operates on Linux-based operating systems, providing developers with a familiar and highly customizable environment that encourages experimentation and modification. This Linux foundation offers extensive flexibility for software development and system customization, making it particularly appealing to developers who prefer having complete control over their computing environment, rather than working within restrictive proprietary systems. However, initial setup procedures can present significant challenges, particularly when configuring the board to boot from NVMe or eMMC storage options, rather than traditional SD card media. These configuration complexities require a solid understanding of Linux boot processes and storage management, potentially creating barriers for users who expect plug-and-play simplicity. Docker compatibility receives official support in marketing materials, but real-world functionality proves somewhat limited in practice, making the platform less suitable for advanced containerized workflows that many modern development environments depend on. This limitation particularly affects developers who rely heavily on container-based development and deployment strategies. For users with solid Linux experience and system administration skills, the RV2 provides a robust development platform with extensive customization possibilities. However, the absence of comprehensive software support for certain specialized applications, such as OpenWRT networking firmware, may significantly limit its appeal to users seeking seamless, out-of-the-box functionality without extensive manual configuration. Networking performance and connectivity analysis. Networking capabilities on the Orange Pi RV2 deliver reliable performance within specific parameters, though they come with notable limitations that affect certain use cases. Wireless connectivity through Wi-Fi and Bluetooth 5 performs consistently and reliably, making it well suited for IoT applications and remote monitoring scenarios, where stable but not necessarily high bandwidth connections are sufficient. The dual gigabit Ethernet ports initially appear impressive on paper and suggest enterprise-grade networking capabilities. But real-world performance reveals inconsistent speeds due to CPU processing bottlenecks that become apparent under heavy network loads. These performance constraints particularly impact scenarios requiring high-speed file transfers, intensive remote access via SSH, or applications demanding sustained high-bandwidth networking. These networking limitations don't necessarily disqualify the RV2 from networking applications, but they do establish clear boundaries around suitable use cases. Projects requiring stable but moderate speed connectivity will find the board performs adequately, while applications demanding consistent high-performance networking may need to consider alternative solutions or accept these constraints as part of the overall system design. Energy efficiency excellence. One of the most impressive and genuinely standout characteristics of the Orange Pi RV2 lies in its exceptional energy efficiency metrics that set it apart from many competing single-board computers in its price range. During idle operation, the board consumes approximately 1.5 watts of power, while under full computational load, power consumption reaches only around 5 watts maximum. This remarkable energy efficiency creates significant advantages for projects requiring continuous operation over extended periods, such as industrial automation systems, long-term IoT deployments, or remote monitoring installations where power consumption directly impacts operational costs and battery life considerations. The low power requirements also reduce cooling requirements and enable deployment in environments where heat generation and power availability represent significant constraints. For energy-conscious users and applications where operational efficiency matters more than peak performance, these power consumption characteristics represent a compelling advantage that can justify the RV2 selection over more powerful but less efficient alternatives. Optimal application scenarios. The Orange Pi RV2 excels in specialized applications rather than general-purpose computing scenarios. And understanding this distinction is crucial for successful implementation. Industrial control applications represent an ideal use case where the board's GPIO interface capabilities and energy efficiency combine to create reliable automation platforms for manufacturing environments, process control systems, or building management applications. Internet of Things deployments particularly benefit from the RV2's combination of low power consumption, wireless connectivity options, and dual NVMe storage capabilities. Providing a stable platform for data collection, lightweight processing, and remote communication in distributed sensor networks or smart city applications. Media playback applications perform adequately within the board's limitations, supporting 1080p content delivery and downscaled 4K video for digital signage, media centers, or simple entertainment systems, where ultra-high definition isn't required. Lightweight artificial intelligence workloads, including image recognition, basic machine learning inference, or simple computer vision tasks, fall within the board's capabilities without overwhelming its processing resources. Headless operation represents another strength, making the RV2 particularly suitable for server applications, embedded systems, or remote installations where display connectivity is unnecessary and remote management through network interfaces is preferred. Challenges and real-world limitations. Despite its strengths in specialized applications, the Orange Pi RV2 faces several significant limitations that potential users must carefully consider before committing to the platform. Desktop computing performance represents perhaps the most notable constraint, where the board's limited graphics processing capabilities and overall computational resources make it unsuitable for demanding desktop applications, advanced video editing, or intensive multitasking scenarios that modern users typically expect. Thermal management emerges as another significant concern during sustained heavy workloads, where the RV2 generates substantial heat that can impact performance stability and potentially damage components without adequate cooling solutions. This heat generation necessitates additional cooling hardware and careful thermal design consideration in enclosed installations. Software ecosystem support, while improving, still lags behind more established platforms like Raspberry Pi, creating situations where certain applications, drivers, or specialized software packages may lack full functionality or require significant manual configuration to achieve desired results. But here's where it gets controversial. Are these limitations actually deal breakers, or are they simply the inevitable trade-offs that make the $40 price point possible? The tech community remains divided on whether these compromises represent smart engineering choices or fundamental flaws that limit the platform's real-world utility. Value proposition and market positioning starting at just $40. The Orange Pi RV2 establishes itself as one of the most affordable entry points into RISC-V computing architecture, currently available to consumers and developers. This aggressive pricing strategy makes it particularly attractive to hobbyists, students, and developers, interested in experimenting with emerging processor architectures without making substantial financial commitments. However, the relationship between price and value becomes more complex when considering the board's limitations in desktop performance, software support breadth, and thermal management requirements. For users seeking versatile, high-performance computing platforms capable of handling diverse workloads, the RV2's constraints may necessitate considering more expensive alternatives that offer greater capability breadth. For targeted applications in industrial automation, IoT deployment, or lightweight AI development, the RV2 delivers exceptional value by providing necessary functionality at a price point that enables widespread experimentation and deployment. The key to maximizing value lies in matching the board's specific strengths to appropriate application requirements rather than expecting it to excel across all computing scenarios. And this is the part most people miss. The RV2's true value isn't in replacing existing computing solutions, but in enabling new applications that were previously economically unfeasible at higher price points. What do you think? Does the Orange Pi RV2 represent the beginning of a genuine shift toward affordable specialized computing? Or is it just another overhyped budget board that promises more than it can deliver? Have you experienced similar trade-offs between affordability and performance in your own projects? And where do you draw the line between acceptable limitations and deal-breaking constraints? Share your thoughts and experiences. The future of budget computing might depend on how we collectively navigate these challenging compromises.